Hey guys, how you doing? So what we are going to do today is we are going to connect this logic schematic diagram right here. So obviously we have three different logic gates. We have one NOT or inverter, we have one AND gate, and we have one OR gate, and we have two inputs, A and B. So let's open our browser and type multisim.com. Okay, and then when you get there, you will see a blank canvas right like this one. So what I'm going to do first is I'm going to add the three logic gates that we need. So we have one inverter, or this is also known as NOT gate. Now as you can see, the label is somewhat bizarre. Okay, it doesn't seem right, so let me change the name or the label. So just go to the upper right corner and you will see the gear symbol. Just click on that, and the first one that you see here is the ID. So just change that to, what is that, inverter, or we can use the shorter name, which is the NOT gate. Okay, so NOT gate, like what we have discussed earlier, NOT gate has one input, and of course there's only one output. Now the output of the NOT gate, let's go back to the circuit. The output of the NOT gate is connected to one of the inputs of the AND gate. So let's add one AND gate. So we need the two input AND gate. So just click on this. And one of the inputs is connected to the output of the NOT gate. So again, let's rename it. So let's name it AND gate. Then the output of the AND gate is connected to what? It's connected to one of the inputs of the OR gate. So let's add one more gate, and that is the OR, the two input OR gate. Now one of the inputs is connected to the output of the AND gate, something like that. And let's change the label, the name, which is OR. Okay, now let's add the two inputs. So inputs are power supplies. So we will be needing 5 volts. So that's direct current, that's DC voltage. So I will be needing 1, and let me rotate it. Then let me copy that. Just click on the lower right circle right here. This is copy or duplicate. Then let me put it down here. Okay, so I have now 2 inputs. So let's keep the names V1 and V2. V stands for voltage, and it's just 5 voltage because an IC doesn't need a very large amount of voltage. Okay, otherwise it will blow up. Okay, if you supply too much voltage to the IC. We have 3 logic basic gates: the NOT, the AND, and the OR. We have 2 inputs. The voltage one corresponds with input A, and V2 corresponds with input B. Okay, now you see the labels 1 and 2 here, so we don't need it. So just click on it and make sure that you go to the setting again, and the last option is display. Just click or uncheck the net labels so that it won't appear anymore, so it disappears. So again, one more, click on the 2 right here and just go to display and make sure you uncheck the box. There you go. So I think it's much better. It's cleaner right now. Our circuit is much clearer and cleaner. Now let's continue the circuit connection. Now the second input of the AND gate is connected also to input A. So I will just go, by the way, before that, the input of the inverter or the NOT gate is connected to input A, and this is input A. So all I have to do is to click and drag, okay, and then connect that to NOT gate. Also, the second input of the AND gate also comes from input A, right? So I will be needing another wire right here. So let me, there you go. So wait, let me change this V1 to A, much better, so it would be clear. And this is input B. There you go. Now much better. Then the second input of the OR gate is connected to input B. So this is our input B. Then click and drag to draw a straight line, and there you go. So right now, so all inputs are connected to 5 volts, meaning to say there's power. Okay, the power is on. Now, if the power is on, so therefore the signal here is of logic 1, and if you invert 1, it becomes 0. So the first input of AND gate is 0, and the second input of the AND gate is 1. So 0 and 1, and that gives us 0. So the first input of this OR gate is 0. And then the second input of this OR gate is 1 because it's connected to 5 volts. So 0 or 1, the output is 1. Now, in order for us to know if the output is 1, let's have like an LED. So we would know if the input, the signal rather, is really 1. So if the signal is 1, this LED lits. Okay, so this will light up if the output of OR is of logic 1. If the output of this OR gate is of logic 0, this LED won't turn on. Okay, this will be off. And then the negative side, the negative node or the other side of this LED must be connected to the ground. So the ground comes from here, so make sure that we connect the ground to this side of the LED. Now the LED has 2 polarities. One is the positive, the one on the triangle side, and the negative polarity is on the bar side. So make sure that the negative polarity of the LED is connected to the ground. Okay, ground means 0 volts. Now again, let me remove this label right here. So uncheck the net labels box, and let me rename the LED to let's say output. Let's put output, so it would be much better, much clearer. Next, but as you can see, if you have 2 inputs, you have 4 input combinations, right? We have 0, 0. Where is my, there you go. This is the truth table that we discussed earlier or previously. So right now, all inputs are connected to the power supply, 5 volts each. So our inputs, our input combination for that is 1, 1. So the LED must lit up, right? Must turn on. So if I run this, if I click on display button or the run simulation button, the LED must turn on, right? It's up. There you go. So our output is 1, which is correct. If the power supply represents the input of logic input 1, what does input of logic 0 represents? Okay, so that's represented by a ground. So let me have two ground symbols right here, and one is for input A and the other one is for input B. So if our input combination is 0, 0, it means to say that the input is connected to 0 volts, and that is the ground, right? So all I have to do is to remove this line, and I'm going to get the connection from here. Okay, there you go. And B, of course, B is connected to the ground as well. Okay, whatever. There you go. So if I run this, this turns off, right? So let me run it. Where is it? There you go. So the LED turns off if the inputs are both zeros or of logic 0. So again, if the input is 1, of logic 1 I mean, so it means that it's connected to 5 volts. If the input is of logic 0, that means that it's connected to the ground. Okay, so as simple as that. That's it. So let me just clean this up, remove all the labels that we don't need. What else? There you go. I hope this is clear enough for you to understand. Thank you for watching. Till next time. Bye-bye.